Okay, imagine this. Just pure chaos. A mass extinction event, right? Like the one 66 million years ago, asteroid hits, dinosaurs gone, you know the story.
Total devastation.
Exactly. You'd think, okay, complete reset, everything obliterated. But what if survival isn't just about like which species squeaks through?
What if it's something else?
Well, yeah, what if it's about the fundamental jobs in the ecosystem and how those jobs get filled afterwards in ways you just wouldn't expect?
That's a really interesting angle.
It really is. And it's the core idea in this fascinating new study we're diving into today. It sort of challenges some big assumptions about how life bounces back after these planet-shaking catastrophes.
And they used, what, clams and mussels as their evidence?
Yeah, exactly. Fossilized clams, mussels sounds humble, but incredibly revealing, apparently. So our mission here is to pull out the key insights. What did these fossils tell scientists about the ocean, before and after? And what's the takeaway for us?
Okay, yeah, let's set the scene. So the in-Cretaceous extinction, 66 million years back, it's the big one everyone knows.
Yeah, the dinosaur killer.
Right, but it was much more than just dinosaurs. It's one of the big 5 mass extinctions in Earth's history. We're talking over 75% of all known species just gone.
75%. It's almost impossible to really grasp that scale of loss.
It is a truly profound biological reset. And it's worth remembering, a lot of scientists think we're heading towards a 6th one right now.
Which makes understanding the past even more critical. So with 75% of species wiped out, you'd naturally assume entire ecological functions, entire ways of life must have just vanished too.
That's the logical assumption, absolutely. And that's where this new research comes in. It's by folks like David Jablonski at University of Chicago, Stuart Eady at the Smithsonian, Katie Collins at the Natural History Museum in London.
And they focus specifically on the oceans around that time.
Exactly. Marine life, right before and right after the impact.
Okay, so why the mollusks? Clams, oysters, mussels? Why them?
Well, it's all about the fossils. They're hard shells. Fossilize really, really well. They're abundant. So you get this fantastic continuous record preserved in rock layers.
Ah, okay. So they provide a really detailed picture of who was living there over long stretches of time.
Precisely. But here's the really clever bit, the crucial part of their method. They didn't just count species. Stuart Eady put it nicely. They decided to count ways of life.
Ways of life, not just A clam versus B clam, but what were they doing?
Exactly. How did they make their living? Were they stuck to rocks? Did they burrow deep in the mud? Were they predators filtering water? That kind of thing.
So they were mapping out the jobs, the ecological roles.
Yeah, they built this picture of the global ecological landscape, as David Jablonski called it. You get this great image looking at the ecosystem before the roof came in.
Before the asteroid hit.
Right. And then they painstakingly compared that map of jobs to the fossil record from after the extinction event.
Okay, so they have this detailed map, all the different jobs mollusks were doing, then bam, 75% of species vanish. You'd think that job map would look like Swiss cheese afterwards, right? Huge holes where functions just disappeared.
That is entirely what you'd expect, logically. But here's finding number 1, and it's a big one. Despite 75% of the species disappearing, virtually none of those ecological roles, those ways of life, were lost.
Hold on. 75% species loss, but the jobs mostly remain. How does that even work?
It seems completely counterintuitive, doesn't it? Katie Collins called it extremely statistically unlikely.
You bet.
Yeah, I mean, she pointed out if 75% die out, you'd expect some ways of life to vanish completely, especially if, maybe only 1 or 2 species were doing a particular job.
Right. If those 1 or 2 species get wiped out, the job should disappear with them, but it didn't.
Apparently not. They found the overall functional structure held up. Jablonski called it a really interesting and slightly disquieting finding.
Disquieting.
Yeah, I can see that. It suggests maybe we don't fully grasp the link between species numbers and ecosystem function.
Exactly. We don't understand how loss of biological diversity, like species counts, relates directly to the loss of these functional groups.
So this throws a wrench into some existing ideas about mass extinctions then.
It definitely challenges them. There are kind of 2 main schools of thought. One is that extinctions just speed up the inevitable, the groups already on the rise, like mammals after dinosaurs, just get a boost.
Oh.
The other idea is that mass extinctions create these vast, empty ecological landscapes, and the few survivors rapidly diversify to fill all the newly vacant roles or niches.
But wait, if the study found the niches didn't actually disappear, then that second model doesn't quite fit either, does it?
Not perfectly, no. The functional landscape wasn't really emptied out in the way that model suggests. The jobs stayed, even though the species doing them were devastated. Okay, so the jobs remained, but obviously the workforce changed dramatically. What did they find about the recovery process? Did the survivors just kind of slot neatly into the existing roles and carry on?
No. And that's the second really key finding. The recovery, the way species bounced back, was described by Stuart Eady as scrambled.
Scrambled. Okay, that sounds messy.
It implies a kind of unpredictability. It means that just because a particular group of species survived the extinction event, that didn't necessarily predict how things would look millions of years later.
So surviving the initial catastrophe didn't guarantee you'd be a long-term winner or that your way of life would become dominant.
Pretty much.
Yeah.
You might think a genus, like a group of related species that had lots of survivors, would naturally go on to wind up on top later on, as Edie said. But it wasn't that simple.
Interesting.
And Jablonski added that even if a particular way of life, say burrowing in mud, had lots of surviving species right after the impact, that didn't mean that way of life stayed packed with species long term. The patterns got reshuffled.
So it wasn't like the textbook idea of survivors just rapidly radiating out to fill empty spaces, at least not here in the marine mollusk world. Maybe it was different for mammals.
It might have been different on land, yeah. Mammals diversifying after dinosaurs is the classic example. But this marine study shows a much less predictable, sort of scrambled pattern of recovery.
Is there a specific mollusk example that shows this scrambled effect?
Yeah, they mentioned the Scabrotrigonia lineage. Think of it as a group, like a family of clams. Before the extinction, they were everywhere, really diverse.
Okay. Sounds like a prime candidate for a strong comeback.
You'd think so.
Yeah.
But today, there are only a few species left from that whole successful group, and they're only found off the coast of Australia.
Wow. So super successful before, survived the hit, but then kind of faded away globally afterwards.
Exactly. It perfectly illustrates how initial survival didn't guarantee future dominance or even widespread presence. The whole ecological picture got completely rearranged.
Okay, so let's connect this to today. The basic ecological structure, the jobs, can survive even massive species loss. But who does those jobs gets totally unpredictably reshuffled. Why is knowing this so important for us now?
Well, because, as Jablonski really emphasized, this has direct relevance to the biodiversity crisis we're facing today, the potential sixth mass extinction.
Especially in the oceans.
Absolutely. Our oceans are under immense pressure, acidification, pollution, overfishing, warming. Billions of people depend on them.
So understanding how ocean ecosystems responded to past crises could inform how we manage them now.
That's the hope.
Yeah.
Jablonski made the point that if we're thinking about conservation or managing ocean resources, maybe we need to look beyond just saving individual species, as important as that is.
We need to think about the bigger picture.
Right. Consider the larger ecological structure of the biota, he said. Think about maintaining those fundamental functions, those ways of life, recognizing that the specific species performing them might shift or scramble over time, especially under pressure.
So the big surprise here is this resilience of the ecosystem's function, even while species are vanishing wholesale. But coupled with this complete unpredictability about who ends up doing those functions long term, survival doesn't equal dominance later on.
Exactly. It shows ecosystems might be, in the functional sense, more resilient than we thought to just species loss alone. But it also paints a picture where the future makeup of life after a major shock is really hard to predict based just on who initially makes it through.
It's scrambled. So if these core ecological roles can endure even when most species die out, what does that suggest about what's truly fundamental for life's persistence on Earth? And, how should this idea of a scrambled recovery make us rethink how we approach conservation today?
Definitely something to mull over.